Gaussian Mixture Models, or GMM, is a probabilistic clustering method that assumes data comes from a mixture of Gaussian distributions. At the core of GMM is the Gaussian or normal distribution, characterized by its bell-shaped curve. It's defined by two parameters: the mean mu, which centers the distribution, and the variance sigma squared, which controls its spread. The mean mu determines where the peak is centered, while the standard deviation sigma controls the width of the distribution. A Gaussian mixture model combines multiple Gaussian distributions, each with its own mean, variance, and mixture weight. The weights represent how much each component contributes to the overall distribution. GMM uses the expectation-maximization algorithm, which alternates between two steps: the expectation step, where we compute probabilities of each point belonging to each cluster, and the maximization step, where we update the Gaussian parameters based on these probabilities. Iteration 1. Points are colored by their most likely cluster. The Gaussians are updated to better fit the data. Iteration 2. Points are colored by their most likely cluster. The Gaussians are updated to better fit the data. Iteration 3. Points are colored by their most likely cluster. The Gaussians are updated to better fit the data. Iteration 4. Points are colored by their most likely cluster. The Gaussians are updated to better fit the data. Iteration 5. Points are colored by their most likely cluster. The Gaussians are updated to better fit the data. After several iterations, the algorithm converges to a solution where each Gaussian fits one cluster in the data. Notice how points can have partial membership in multiple clusters, unlike k-means, which makes hard assignments. A key advantage of GMM is soft clustering. Each point has a probability of belonging to each cluster. For example, this point has a 40% chance of belonging to the red cluster, 50% to green, and 10% to blue. GMM has several advantages over k-means, including soft clustering and flexible cluster shapes. However, it requires specifying the number of components, is sensitive to initialization, and is slower than k-means. GMM finds applications in many domains, including anomaly detection, image segmentation, and speaker recognition. Its probabilistic nature makes it particularly useful when we need uncertainty estimates. In summary, Gaussian mixture models offer a powerful probabilistic approach to clustering. They model data as coming from a mixture of Gaussian distributions, provide soft clustering assignments, and can adapt to different cluster shapes through the covariance structure.